What's next question? It reads as, if a is greater than 0, if a is positive, and a raised 2x is equal to under root 2 plus 1, find the value of a raised 3x plus a raised minus 3x divided by a raised x plus a raised minus x. We have some conditions. A is positive and a raised 2x is equal to under root 2 plus 1. Find the values of a raised 3x plus a raised minus 3x divided by a raised only x plus a raised minus x. A raised minus x. We have given some limitation value. A is positive. A is positive. We can deal with it. A raised 2x is equal to under root 2 plus 1. A raised 2x is equal to under root 2 plus 1. It's our game changer. It's our game changer. It is something special. It is something special. Before putting value here, simplify this. Simplify the question. A raised 3x. It can be written as, turn the exponent positive, write the a raised negative 3x in denominator as 1 upon a raised positive 3x divided by, similarly, a raised x, turning negative exponent to positive, writing in 1 over a raised x. I have done nothing. A raised negative 3x, I have written 1 over a raised 3x. And in denominator a raised minus x, I have written 1 over a raised x. I have turned the negative exponent to positive mathematically. Taking LCM here, taking LCM, it will become a raised 6x plus 1 divided by a raised 3x. A raised 3x times a raised 3x. A raised 3x times a raised 3x. Bases are same. Add the power 3x plus 3x, it will become a raised 6x. I have written. Similarly, taking LCM here, it will become a raised 2x plus 1 divided by a raised x. I have taken LCM of this one, taking LCM of this one, taking LCM of this one. Okay, cool. Or in order to give you good view, maybe they seem similar steps to you because of this division. Okay, let me clarify the situation further. If we can write this, a raised 3x plus a raised minus 3x. Instead of this upon, let me write divide a raised x plus a raised minus x to give you good view. Turning this negative exponent to positive, turning this negative exponent to positive, same, working along same lines. A raised 3x plus 1 divided by a raised 3x divided by, turning this exponent to positive first, then taking LCM, a raised x plus 1 over a raised x. Taking LCM, here's one, taking LCM, we have a raised 3x is our LCM, a raised 3x times a raised 3x, adding the powers, it will become a raised 6x plus 1. Similarly, a raised x times a raised x, it will become a raised 2x plus 1 divided by ax, turning this division into multiplication by taking the reciprocal of the quantity, proceeding this division sign, a raised 6x plus 1 divided by a raised 3x. Then this one can be written as a raised x divided by a raised 2x plus 1. Here a raised x, a raised 3x. If I cancel them out, I have a raised 2x in the denominator. A raised x and in denominator a raised 3x. Here the greater power, something remains here. 3x minus x, it will become a raised 2x, a raised 2x. Look at this one, a raised 6x plus 1, a raised 2x plus 1. A raised 6x plus 1, a raised 2x plus 1. There lies the relation, It can be written as in cubed form. This is also in cubed form. This quantity a raised 2x is a factor of this one. This quantity a raised 2x is a factor of this quantity. By virtue of the property or formula, a cubed b cubed is equal to a plus b, a square minus ab plus b square. Applying this identity here, we can easily manage this quantity. We can easily afford this is a factor of this one. Let's simplify the situation. Let me make space for myself. We have a raised 6x plus 1. What is left? A raised 2x plus 1 over a raised to x plus 1. Now I am going to use this identity a cubed plus b cubed. It's equal to first bracket without cube a squared negative a times b plus b squared. Utilizing this formula, this identity here, I can write this one as a raised to x plus 1 and second bracket square of this, it will become a raised 4x, changing the sign first into second, a raised 2x plus 1 divided by a raised 2x, as well as this quantity in the denominator a raised 2x plus 1. It is no more, it's a common factor. I have utilized the fact a raised 6x plus 1. A raised 6x can be written as a square a raised 2x whole cubed plus 1 cubed. I have utilized this identity here. First bracket without cube, square of first, it will become a raised 4x. Change the sign, multiplying first into second, a raised 2x into 1 plus the square of 1 is 1. I have utilized this identity according to this here. What we are left with, just put values and we are going to arrive at our result. A raised 4x minus a raised 2x plus 1 divided by a raised 2x. We have the value of a raised 2x, this magical figure prevalent here. A raised 2x, there is a raised 2x, there is a raised 4x. So this a raised 4x can be written as a raised 2x whole squared minus a raised 2x plus 1 divided by a raised 2x. Just put value here, under root 2 plus 1, under root 2 plus 1, under root 2 plus 1, and it is going to be our final answer in that case. Making again space for myself, I have, instead of a raised 2x, let me write under root 2 plus 1 whole square. Value is given to us, minus under root 2 plus 1 divided by under root 2 plus 1. Open up, apply a plus b whole square, perfect square quantity formula. It's equal to under root 2 square plus 2 times square root of 2 times 1 plus square of 1. Multiply minus, minus under root 2 minus plus minus plus 1. No more. Square of root 2 is only 2 plus 2 times root 2 plus 1 minus under root 2 divided by under root 2 plus 1. Here square of under root 2 is only 2. 2 times under root 2 times 1, it is 2 under root 2. Square of 1 is 1. That is we are left with. Here again we have to take some trouble. 2 plus 1, it's 3. 2 plus 1, it's 3. Add them up. That is 2 under root 2 minus 1 under root 2. 2 under root 2 minus 1 under root 2. 2 under root 2 minus 1 under root 2. Like 2x minus x. Like 2x minus x. 2 under root 2 minus under root 2. 2 under root 2 minus under root 2. We are left with 1 under root 2 divided by under root 2 plus 1. 2 plus 1, that's our 3. 2 under root 2 minus 1 under root 2. 2 under root 2 minus 1 under root 2. Let me clarify the situation. 2 under root 2 minus under root 2. Taking under root common. Under root 2 common, what we are left with? 2 minus 1. So it is equal to under root 2 times 1 that I have written. Okay. Again, square root is in the denominator. Rationalizing by rationalization. By rationalization we have changing this sign, taking the conjugate of this one, under root 2 minus 1, under root 2 minus 1. Multiply them up. 3 times under root 2, it will become 3 under root 2. 3 times 1, that is negative 3. Under root 2 into under root 2, that's only 2. Under root 2 into minus 1, that's minus under root 2. And here nothing more, a plus b, a minus b, difference between 2 square. It can be written as under root 2 square minus 1 square. Under root 2 square minus 1 square. Making again space for myself. Now eventually we are going to arrive at our required destiny. That is the answer of this question. We have minus 3 plus 1. Let me write this step again. 3 under root 2 minus 3 plus 2 minus, that is mine, under root 2 minus under root 2 divided by Under root 2 square means 2 minus 1. Denominator have 1, we have got rid of this. Minus 3 plus 2, that's minus 1, that is 3 under root 2 minus under root 2. 3 under root 2 minus under root 2. Like 3x minus 1 minus x. 3x minus x. We are left with 2 under root 2. And here minus 1 upon 1. Means our simple answer is 2 times under root 2 minus 1. 2 times under root 2 minus 1. So E is the right option in that case. E is the right option in that case. It's my tiny effort for you guys to produce in front of you some good questions. See you.